So now, let's try and create some formulae, whatever the plural is, for geometric series. So like we did with the arithmetic, let's just write down all the terms. So first term's A, next one's AR, and so on up to AR to the n minus 1. All right. Now with the arithmetic one, I rewrote it. I'm not going to rewrite it this time. I'm going to multiply by something and rewrite it. I'm going to multiply by R. So the A becomes AR, the AR becomes AR squared, and so on and so on. But then I've slightly shifted each term there to make it a little bit more obvious what's going to happen. All those terms are going to cancel if I do a subtraction. So if I subtract, I suppose it doesn't really matter whether I go top minus bottom or bottom minus top. I went bottom minus top. So I'll have AR to the end because there's nothing to cancel there, but then it'll be minus A. Divide both sides by R minus 1. Bit of factorising. So we get our formula. A, R to the power of n minus 1 over R minus 1. Now, traditionally we use that formula if the ratio, and I'm just talking about the magnitude, I don't care about positive or negative, but traditionally we use that when it's greater than 1. You don't have to. The other formula, of course, could be this one. A, 1 minus R to the n over 1 minus R. And as I say, traditionally we use that one if it's less than 1. And I suppose the only reason is if we're talking about positive ratios, it's to leave a positive number in the denominator. So if you've got a ratio smaller than 1, then 1 minus it will be positive. But if it's bigger than 1, it would be negative. So we use the other one, R minus 1. But they're exactly the same because the only difference, of course, is the bottom one is the top one where I've multiplied both top and bottom the fraction by negative 1. So, I mean, you could use whichever one you like. Now, geometric ones have this other sum that we like looking at because it's far more interesting, and that's a limiting sum. So you can get an infinite number of terms, and even though there's an infinite number of terms, we can still add them and come up with a finite answer. And that works so long as the terms, what we call, converge. Fancy way for that, let's just write it, is if the ratio is smaller than 1. So the terms, if you like, are getting smaller and smaller and smaller and smaller. So each term's getting closer and closer to 0. So if the ratio is less than 1, then we know that the limit as n approaches infinity of r to the power of n is equal to 0. Because if you think of the curve, but remember the ratio is less than 1, so if you had a fraction to the power of n, your exponential curve, but it'd be the one where it goes down and goes asymptotic to the x-axis. So at an infinity, it's getting closer and closer to 0. So if that's true, the limit of our sum, well, r to the power of n will approach 0, we know that. So we end up with just a on 1 minus r. And so that's where the formula comes from. Sum to infinity, a on 1 minus r. But, as I say, it only works if that ratio is in between minus 1 and 1. Some of the first 10 terms, so first term's a is 2, ratio r is 3, number of terms n is 10. Substitute it into our formula, and we get 2 outside of 3 to the power of 10 minus 1 over 3 minus 1. Depending on your calculator, the older type of calculators, you'd probably actually work out what's in the parentheses first and then go and do it. But I think modern ones can pretty much handle just plugging it all in. We end up with 59,048. Sum notation. Now, it is the sum of a geometric because there's our general term, 6, half to the power of n minus 1. But notice the first term is when n equals 3, not when it equals 1. So, there's my first term, I can work that out. 3 on 2. The ratio is a half. Now, you should recognise it from the formula, but if you didn't, then I suppose, okay, you could go and work out what term 2 is, and then from that, work out the ratio. Number of terms, remember, be careful, it's inclusive. So 8 minus 3 is 5, but plus 1. We're going to have 6 terms. So, submitting it. Now, again, depending on your calculator, whether you try and do that all in one hit, especially when you start doing fractions to powers. Although half's pretty easy, but some of the other ones calculated will go and changing the decimals on you. Half to the power of 6 is 1 minus that would be. Okay, so you got 63 on 64 times 3 on 2 divided by 1 on 2, so the on 2's cancel. We're now at 3 times 63 on 64. 3 times 63. 189 on 64. There you go. Sometimes I like to throw these little questions in just to see if you know the definition, basically, of what makes a geometric series have a limiting sum. So it's how does it? So yes or no. Mind you, it's not like it's a coin toss. You usually got to give some sort of reasoning behind it. You can't just go yes and hope for the best. I hope I pick the right one. So in this case, the ratio turns out to be 4 on 56. You get that no matter which term you grab. 4 divided by 56 is obviously 4 on 56. But 2/7 over 4 is also 4 on 56. So as that ratio is less than 1, yes, it does have a limiting sum. Don't waste time. It hasn't actually asked you to find the limiting sum. So. The frog in the well. Classic question, right? So this is basically what this is. You got a well and there's a frog at the bottom. You know the one? Yeah? So it can jump halfway up, but then the next time it can only jump half as much again, then half as much again, half as much again. Does he ever get out of the well? Is the question. I mean, he's a pretty stupid frog when you think about it. But let's see. So first term is a half. Ratio is also a half. Sum to infinity. So if you had an infinite number of jumps, he'd get a half on 1 minus half, which is just 1. So he'd end up right on the edge of the well with an infinite number of jumps. We, of course, have seen questions like this before. Answer?
36.
Right. So if we use our quick way of doing it, it comes out nice and easy. Sometimes, though, they might handcuff it. They might say, write it as a fraction by expressing as an infinite sum or something like that. So 0.36 repeater we can write as an infinite sum because it would be 0.36 plus 0.0036 plus 0.00036 plus 0.0000036 plus 0.000000036 plus 0.00000000036 plus 0.00000000036 plus, well, I'll be here forever if I was to say the whole infinite sum, of course. First term, 0.36, ratio, 0.01. So sum to infinity, 0.36 over 1 minus 0.01, which is 36 on 99, which simplifies down to be 4 on 11.